Presentation, we have talked about the concept mean free path. The concepts free path and mean free path are vital while studying the motion of a molecule inside a gaseous medium. As you know that suppose a molecule is making its movement inside a gaseous medium, it has the opportunity to collide with other molecules. As a result of the collision, the path traced out the molecule is zigzag. At this moment, we may coin the terms free path and mean free path. The path covered by a molecule between successive collisions is called the free path, whereas the mean free path is the mean distance traveled by a molecule between two successive collisions. Now, read out this statement. When a molecule of finite size moves in a gas, it collides with other molecules. As a result, its direction changes. See here, this molecule is colliding with this molecule A and its direction is changed. After that, it is colliding with the molecule B. Once the direction is changed, it is colliding with molecule C. Therefore, the molecule may move in zigzag path as shown in the diagram. The path traced out by the molecule is zigzag. The diagram shows that AB, BC, CD, DE and so on are free paths. AB is a free path, BC is a free path, CD is a free path, DE is a free path, but are having different length factors. Some of the free paths are short while others are long. The average length of these free paths is referred to as the mean free path. Just if you take the average of all these length factors, you may get the term mean free path. We will denote the mean free path by the symbol lambda. If lambda 1, lambda 2, lambda 3 and lambda n are successive free paths traversed in time t, and n is the total number of collisions, then mean free path lambda is equal to lambda 1 plus lambda 2 then lambda n whole divided by capital N. See here, lambda 1, lambda 2, lambda 3 are successive free paths. If you take the sum of these and then divided by the total number of collisions, we can get our mean free path. This is equal to total distance travelled divided by total number of collisions. The following assumptions are made to get an expression for the mean free path. The first assumption is only one of the molecules under consideration is in motion while the others are at rest. See here, this molecule alone is in motion, all other molecules are at rest. The molecule's sphere of influence has a diameter d. If you consider r be the radius of a molecule and the sphere of influence of a molecule is d, this means that a collision between two molecules occurs only if the separation distance between their centers is d. If the separation distance between the two centers is d, the collision is taken place. Suppose the distance of separation is more than d, there is no talk about collision. This is called the sphere of influence. If c is the molecule's velocity, then in 1 second it will collide with all the molecules the centers of which lie within a cylinder of radius d and length c. Assume that all the molecules are present inside a cylinder of radius d and length c. If c be the velocity of a molecule, then in 1 second that molecule will make collision with all other molecules. You know the volume of the cylinder. Suppose d be the radius of the cylinder and c the length of the cylinder. Volume of the cylinder is equal to pi d square into c. This is the volume. The general formula for volume is pi r square h. Here r is replaced by d, then h is replaced by c. Then the volume of the cylinder is pi d square into c. Let small n be the number of molecules per unit volume. Therefore, the number of molecules in the cylinder is pi d square c into n, because small n be the number of molecules per unit volume. The total volume of the cylinder is pi d square c. Therefore, the total number of molecules inside the cylinder is pi d square c into n. This total number is equal to the number of collisions per second. Once again, concentrate on this. This is very, very important. If n be the number of molecules per unit volume, then the number of molecules in the total volume of the cylinder is pi d square c into n. This could be equal the number of collisions per second. We know that the number of collisions per second is known as frequency of collision. This is f. F is equal to pi d square c into n. We know that frequency equal to 1 by time. Therefore, average time between two successive collisions t equal to 1 by frequency. We know that frequency equal to 1 by t, time equal to 1 by frequency. Average time between two successive collisions t equal to 1 divided by pi d square c into n. Now we should calculate the average distance travelled by a molecule between two successive collisions, which is called as mean free path. You know that velocity equal to distance by time. We need the factor of distance. Distance equal to velocity into time. We need the distance. Distance is our mean free path. That is equal to velocity c. C be the velocity of the molecule. Here we have taken c into t. In our case, we have assumed that the velocity of the molecule is c. So c into t. Distance equal to velocity into time. This is the general formula. Here the distance is our mean free path, which is equal to velocity of the molecule c into time. We know the time factor. Time is 1 divided by pi d square c into n. This is average time between two successive collisions. If you carry out, we may get the value of lambda is equal to 1 divided by pi d square n. This is called mean free path. The quantity pi d square is called microscopic cross section of the molecule. If you consider a single molecule, that molecule's microscopic cross section is pi d square, because molecule is having its spherical shape and is denoted by the letter sigma. Therefore, lambda equal to 1 divided by sigma n. Here sigma equal to pi d square and is called the microscopic cross section of the molecule. Clausius considered that all the molecules move with a constant velocity in all directions and proposed a relation lambda equal to 3 by 4 pi d square m. Say in this relation, Clausius introduced the factor 3 by 4. Therefore, lambda equal to 3 by 4 into pi d square n. According to Maxwell, lambda equal to 1 by root 2 into pi d square n. Introduce the correction factor root 2. Now we have to study the effect of pressure on mean free path. We know that the pressure P equal to nKT. K is Boltzmann constant, is our absolute temperature. The N is replaced by P by KT. P equal to nKT, N is equal to P divided by KT. Substitute this value of N in our relation lambda. We know that lambda equal to 1 divided by root 2 into pi d square N. This is our Maxwell's relation. So instead of this N, we should put P by KT. Therefore lambda equal to KT divided by root 2 into pi P d square is the value of lambda. The mean free path is directly proportional to the absolute temperature and inversely proportional to the pressure. So this is the effect of pressure on mean free path. If pressure increases, the mean free path value decreases. If the temperature is increased, the molecules are making their random motion. Therefore, the value of mean free path increases. That's all about the fundamentals of the term mean free path.